Good morning, my dear students. Let me welcome you to my second lesson on assignment problem. Here we have 5 jobs and 5 machines to be matched, to be allocated, so that the overall cost of operation is going to minimum. The matrix says that there are 5 jobs here. Again, there are 5 machines. If job A is allocated to machine 1, the cost that is expected is rupees 10. Similarly, if job A is allocated to machine 2, the cost is 5 rupees. And this is what exactly the job and the machine matrix represents. We have 5 rows and 5 columns. The assignment problem is balanced. Now, to continue with the row minimum operation, look at the first row and identify its minimum. The first row, the minimum value is 5. The second row, the minimum is 3. The third row, the minimum is 2. It is repeated, of course. And the fourth row, it is 7. Again, 7 is repeated here. And the fifth row, the minimum is 4. Row minimum operation says that you have to take the difference, that is 10 minus 5 is 5. 5 minus 5 is 0. 13 minus 5 is 8. 15 minus 5 is 10. 16 minus 5 is 11. And similarly, with respect to the second row here, 3 is minimum. 3 minus 3 is 0. 9 minus 3 is 6. And 18 minus 3 is 15. Likewise, it continues. And we have row minimum that is revised, that is developed. The revised matrix here is 5, 0, 8, 10, 11. And 0, 6, 15, 10 and 3. 8, 5, 0, 0, 0. And 0, 4, 2, 0, 5. 3, 5, 6, 0, 8. And this is row minima. And to continue with the column minima, I take these values and then I compare the column minima values. And look at this column minima. If you say each and every column you have a 0. Look at this. This is a 0 and again 0 and again 0 and again 0 and again 0. And the column minima is not going to be altered. The same row minima will be continued in the column minima too, because 0 is the minimum. And the subtraction of 0, as you know, there is no change in that, because of 0 as the minimum value. Now, if you say that the column minima is the same, now I continue with these allocations. Identify the row having single zeros. And the first row we have 1 0. Second row again we have only 1 0. Third row we have 3 zeros here. Fourth row we have 2 zeros. And the fifth row we have only 1 0. To begin with, identify the first row here. First row we have only 1 0. It is allotted. Job A is given to that is machine 2 or operator 2. And once this is done, you look at the respective row and the respective column. You find any zeros, you have to discard it. Now look at the 0 is there, and no particular zeros in the respective column and respective row, and there is no such kind of deletions or cancellations. After that, you come here, second row, and there is only 1 0, and it is allocated. And once this allocation is marked, look at the respective column, and in the fourth row and the first column there is 0, and you have to discard it. And once that is done, and I'll continue with this fifth row here, E. And now in this E here we have only 1 0, and this is marked. Once this is marked, the respective column zeros are deleted, and look at this, cancellations are marked. Once this is the 2 zeros are cancelled, we are left with only 1 0 here, and again this is marked. And now we have there is a column row D that is not allocated. There is not even one single allocation that is there for this particular row. And identify the unallocated row, put a tick mark. The unallocated row is identified and that is ticked. Look at this. This is the row which is not having any allocation. Now once this allocation is marked, look for the discarded zeros in that respective rows. And here is the discarded 0, and here is the discarded 0. And now the procedure says that Here discarded 0 on the respective column, put a tick. Discarded 0 here, again in the same column and the respective row again here, again put a tick. Now we continue here again. Here is a 0 that is discarded and the respective column there's a tick. Now we have few rows are ticked, again the few columns are ticked. Now draw lines to unticked rows and ticked columns. See, unticked row here, unticked row here, and the two rows are unticked and we have drawn the lines. At the same time, there are two ticked columns and there is a ticked column here and the ticked column here, and these ticked columns are represented on the lines. And while doing this kind of arrangement, ensure that no 0 is left out of your line markings. See, all zeros should lie on these zeros, and it is done. And once this is done, identify the numbers that are not covered on these lines, and you have to identify the minimum of that, and 2 is minimum. The Hungarian procedure says that this 2 to be added to the intersection and 2 to be subtracted from all uncovered elements, and if there is only one line, either column or the row, we have to retain that. That's what exactly I'm doing it now. See, 5 plus 2 is 7 and this 0 is retained because that is only a single line there, and 8 again that single line retained, and it is a plus mark here intersection. 10 added 2 that is 12, and again 11 that is a single line, it is marked 11 as it is, retained 11 as it is. Now 0 retained as it is because there is only one single line there, there is one column line, and again 6 and less 2 it is 4, 15 less 2 is 13, 10 retained as it is, 3 and subtracted from this minimum uncovered that is 2, 3 minus 2 is 1. Now look at this 8, and 8 is added with 10. There's an intersection here. 8 plus 2 is 10. 5 is retained. 0 is retained again. Again 0 plus 2. There's a marking, plus mark, intersection mark. 0 plus 2 is 2. And again 0 here, one single line. You retain as it is. Now again there is one more 0 here. You retain the 0 as it is because there is only one line. And 4 minus 2 is 2. 2 minus 2 is 0. Again 0 retained as it is. 5 minus 2 is 3. And again 3 here, only single line. 5 minus 2 is 3, subtraction. 6 minus 2 is 4, again it is subtraction, uncovered elements. And 0 it is retained as it is because covered only on one line. And again 8 minus 2 is 6. Once this particular Hungarian procedure is followed, we are going to have allocations again. Now see here, we have only one 0 in the column, in the row. Again only one 0 in the row. Again we have 2 zeros here. Again we have 3 zeros here. And we have only 1 0. To begin with, you have to target the rows having only 1 0. And A and 2, that is operator 2 is marked, allocated. Again B with one operator is allocated. Once these allocations are done, you have to ensure that no respective column and no respective row should have zeros and to be deleted. Now here it is marked and there is no respective 0 and the respective 0 here. Respective column and the rows, it is not there, and there is no such cancellations. But when it comes to second row, but here is 0, it is allocated. At the same time, the respective column, there is 0, discard it. And go with the next row here. We have only 1 0 here, only 1 0, and the respective column is deleted or discarded. Now once this is discarded and we have left with only 1 0 here, and this is marked, and finally we have only 1 0 left with this column, third column, and that is allocated. Now the optimum allocation is A with 2 and B with 1 and C with 5 and D with 3 and A with 4. I explain it again. Once these allocations are done, you have to check whether all the allocations are marked for each row and each column. It is marked again, that is 1, 2, 3, 4 and 5. The 5 operators are matched with the 5 jobs. Now that is A with 2, B with 1, C with 5, D with 3 and E with 4. And if you compare with a given problem, if you say A with 2, if you say A with 2, A with 2 is 5, A with 2 is 5, it is marked, and it is marked here. B with 1, if you say B with 1, that is 3, again it is marked. Again C with 5, if you say C with 5, the C with 5 is 2, it is marked here. Again D with 3, that is 9, D with 3, that is 9 here. And E with 4, if you say, that is 4. And addition 5 plus 3 plus 2 plus 9 plus 4, minimum cost is 23 units. This is the optimum schedule, and this is what exactly your Hungarian algorithm and the steps to be followed. Thank you very much.